Welcome to Juniper vLabs lab number 6. In this video, we're going to be taking a look at network address translation. Specifically, we're going to look at a Destination NAT example. So in this video, we are going to have 3 devices. One of them is going to be an external client in the untrust zone. And then we're going to have 2 servers in the DMZ. And so we're going to have to do some initial configuration on the servers for reachability, and then also from host 3's perspective back to server 1 and server 2. So we'll get that set up in a minute, and then we will configure our NAT policies, our security policy, our zones, everything on the vSRX firewall. So again, in this video, we're just going to explain, we're going to go over a little bit of the basics of network address translation. We've looked at NAT now on vLabs number 4, 5, and this is lab number 6. We're going to configure Destination NAT. We're going to perform a bunch of show commands on the firewall for verification that we have proper connectivity and reachability. So you can check out the GitHub link below, and this will be in the description of the video on YouTube. And there we provide you with not only the README file, which gives you a brief overview of the lab, but we also provide you with the initial device configurations and the step-by-step guide. So if you want to follow along, the step-by-step guide is going to have all of the steps that I'm doing that you can follow to learn. So if you're not familiar with Juniper vLabs, we've explained that in vLab number 1, just how to get an account, how to get set up, squared away, and how to log into the portal. We've already done that for you in this lab. If you look on the portal, if you have a login and you go down to the security area, we're going to be using the zones policies lab, that sandbox, so you can just launch that. It takes about 15 minutes, 10 to 15 minutes for the lab environment, the sandbox environment to come up. So we've already done that for you. It's active. We have a good 2.5 hours left to work. So I've already brought up our consoles for the vSRX and the 3 nodes, host 1 and host 2. Those are going to be our server 1, server 2, and then host 3 is going to be our device on the internet, or our external device. So let's go back to the diagram one more time. We're going to set up some custom IP addressing. We're going to use the lab's default IP addressing for server 1 and server 2, those endpoints. And then we're going to have a simulated public IP range. So this is going to be in the 200 subnet. We're going to put that inside the untrust zone between host 3 and the firewall. And then we're going to have our loopback 0, where we're going to simulate our destination NAT IP addresses. And we're going to tie these IPs back to server 1 and server 2. So just the basics about Destination NAT. We're going to use this for devices on the internet trying to reach our servers in the DMZ. We don't want to provide the private IP addresses to the internet. Number 1, they're not routable. Number 2, it's not good security practice to have those IPs, even if they were public facing. You want to hide the identity as much as you can. So we're going to provide you an example of Destination NAT on the firewall, where we will be performing translation from the loopback. We're going to simulate these IPs, and the loopback IPs are going to be tied to, or nailed down to, server 1 and server 2, the private IPs. So loopback 0, so 1.1.1.1 is going to be tied down to the 11.2 IP, the 10.100.11.2 on server 1, and then 2.2.2.2/24. That subnet is going to be tied down to the interface, the 10.0.12.2 IP address. So let's go ahead and get started. So the first thing that we're going to do is we're going to change the IP addressing. Let's go to the VSRX. We'll fire that up. Looks like we lost the connection. So on the VSRX, we're just going to look at the configuration. You see that there's no security policies or security zones. So I've taken those out because we're going to add our own policies and zones than what the default is loaded on the lab. So we have that in the initial configuration. You can use that as your guide to set up the firewall for the lab. So it looks like some of those sessions timed out. No worries, we'll get back into them. So let's go to the VMX. This is again going to be host 1. We'll just go ahead in here. We'll do set system host name. We'll just change this to server 1. Okay. And what we're going to do is we're going to give a route to server 1 to the outside IP address, the untrusted interface on the firewall to simulate the internet. We'll do that in a second. Let's go to host 2. I just want to change the host names first. So we'll go ahead and commit that on both server 1 and server 2. If we go back to our sandbox environment, we'll go to host 3, we'll bring that up. And let's go ahead and create that connection again. If we do a show configuration interfaces, we have the connection between the SRX and host 3 on the 13.2. The 10.100, we're going to change that to 200.0 just to simulate a publicly routed subnet. So we'll do set interfaces gigi 002.0 family inet address, and then we'll do 200.0.13.2. Do a /24 on host 3, and then we'll go ahead and do a delete. This is just a quick way to simulate a public connection. We do a show pipe compare. Okay, we'll go ahead and commit that on host 3, and then we'll go to the firewall, and we're going to do the same thing. So you can see we'll just delete the 002 connection. This is to host 3. We'll delete that IP, and we'll go ahead and set our own. So 200.0.13. What did I say this was? 13.1, I believe. Let's look at our lab. So yeah, 13.2 is host 3, and 13.1 is the firewall. And so this new subnet, what we need to do in server 1 and server 2 is create the route to reach that subnet. So if I just do a show route in server 2, you see that I don't have connection to the public or the internet subnet that we just created, the 200 network. I have a default route that's going to the management, so that's not going to work. So let's go ahead and let's create that route. We'll do set routing options static route 200.0.13.2. 13.0/24, and we'll do a next hop from server 2. The next hop is going to be the VSRX 001 interface, and that's 12.1. So go ahead and put 12.1 in there. And let's go to host 1 or server 1. If I get out of configuration mode and do a show route, you see I don't have the 200 network in there either, so let's go ahead and add that for reachability. It's going to be 200.0.13.0/24, and the next hop from server 1's perspective is going to be excuse me, 12.1. So let's look at our diagram. 11.1. So go ahead and put that 11.1, and that should be it. So we have reachability. We have our routes from our servers. Now we need the routes. We need to build the routes from the host 3 device to the loopbacks. So loopback 0. So we don't have that. Let's go on to there and we'll just verify that. On host 3, if I do a show route, we have a default route to the management, but we don't have anything for the 1 network or the 2 network. So we're going to need that for reachability. Those are our destination NAT IP addresses. So we're going to simulate the firewall has passed these routes down to host 3. And we're going to do that by just creating a static route from host 3 back to the firewall. So simple configuration, doesn't need to be anything complicated. Again, we're not really doing a routing lab here, so we don't need to worry about complexity. We just want to make sure we have reachability. So from host 3's perspective, we just do a set routing options static route, and we'll just do 1.1.1.0/24, and the next hop is going to be 200.0.13.1. So that's the VSRX. So just hit the up arrow, and we'll go back and we'll set up the connection to the 2 network. So now that that's done, let's go ahead and add the loopback interfaces on the VSRX, or those subnets. So we'll do set interfaces loopback 0.0, family INET address 1.1.1.1/24. And then we'll do 2.2.2.2/24. So the 1 network is going to simulate the destination NAT policy that we set up to server 1, and then the 2 network is going to be our connection to server 2. That's going to simulate that connection. Okay, so the next part of the lab is we're going to set up our security zones on the firewall. So we'll do set security zones, security zone, and then we'll name it. So for server 1 and server 2, we'll call it DMZ. And then we'll put our interfaces into the security zone. So this is going to be the connection from the firewall to server 1 and server 2. So this is going to be 000 and 001. Okay, so those interfaces have been defined into the DMZ security zone. Let's go ahead and create our external or our untrusted security zone, and that's going to be the connection to host 3. that interface is 002. So if we do a show security zones on the VSRX, you can see that we have our DMZ security zone, which has 0 and 1 interface in it, and then we have the untrust, which has 002. So the next thing that we want to do is create our address book, and our address book is going to contain our server endpoints. So we're going to use the address book inside of our security policy. So let's go ahead and get those defined. So address book entries are going to be for DMZ server 1 and 2. So we'll just keep it simple in our naming. So we'll do set security zones, security zone DMZ, and then we'll just do address book address. And then we'll call them DMZ server 1, and that's going to be 10.111.2. That's server 1. And that's going to be a /32. And then if I just hit the up arrow and I do DMZ server 2, and that's going to be 12.2. So now that we have our address book created, let's go ahead and define our security policy. And this is policy just to allow the inbound traffic from the internet or the untrust zone to the DMZ. So this policy is needed just to allow the traffic inbound. And then we'll just name the policy. We're going from zone untrust to zone DMZ, and then we're going to create a policy name, and then we'll just call it to web server. And so next we're going to define our match conditions. So we're going to match any source address. So anything coming from the internet. And then we're going to match on the other side is going to be inside of our network. We're going to match the destination address of our address books we created. So we'll do DMZ server and then 1 and DMZ server 2. So now that we have our source and destination IPs inside of our security policy, the next thing we're going to do, if we just hit the up arrow and we go back, we're going to also match on specific applications. So we're going to match application of secure web traffic, so HTTPS. We're going to match on SSH traffic. This is going to be port 22. And last but not least, we're going to match on ICMP or ping traffic. So now that we have all of our match conditions, we're going to set our action, and that's going to be to permit the traffic. So we'll just hit then permit. We'll go ahead and do a commit check, and you can see that the configuration check succeeds. So we'll go ahead and commit that. Okay, if we go back to our diagram, so what we just did is we created a security policy from traffic entering into the untrust zone to the DMZ, and it's going to match specific applications. We have SSH 443 and ICMP traffic. And it also has to match on the destination addresses of the DMZ servers. Now the next portion of the lab is where we actually define our policy, our NAT policy, the destination NAT policy. So remember, we defined our DMZ servers in the address book using their private IPs. So what we're going to have to do now is we're going to take the destination NAT policy and we're going to bind the loopback IPs that we created to the private IPs that are being allowed through the security policy. So let's go ahead and do that. So we'll go back to the firewall and we'll do set security NAT. And then in this case, we're going to do destination. We'll first specify our pool. So we'll just call this DMZ server underscore server is going to be 1. And then I like to do a underscore and then PL. So that helps define this as a pool. And then we'll do address. And then we'll do 10.100.11.2/32. So once we have the pool created, we're going to define the rule set. So we'll do set security NAT destination. And we'll do the command instead of pool, we're going to do the command rule set. And then we're going to give this a custom name. We'll call it DMZ server underscore RS for rule set. And we'll say from zone untrust. So the next command, we're going to be matching the addresses. And this is going to be the destination address. This is going to be the IP address of loopback 0. So we'll use this. We'll create multiple rules. The first one is going to be defining the DMZ server 1. So we'll do set security NAT destination rule set, DMZ server rule set, and then the rule is going to be DMZ server 1 rule. And then we're going to match the destination address of loopback 0. And this is the IP address that we want to bind to the server 1, which is the 11.2. So we'll do 1.1.1.1/32. And then the last thing we're going to do, once we have our match, we're going to have our action. So we'll do set security NAT destination rule set, DMZ server rule set, and then the rule is going to be, if I do a question mark, you see I have one already defined now since I have some configuration already in. So we'll do DMZ server 1 underscore rule. And our action is going to be to then Destination NAT pool, and then the pool that we defined earlier, which is DMZ server 1 pool. So if I do a commit check, let's go ahead and verify that the checkout is good. It succeeds. So let's do a show pipe compare, and we'll run through this. So the first thing we did is we created the pool called DMZ server 1 pool, where we defined the server 1's private IP address 11.2. And then we defined a rule set saying that traffic from the untrust zone is going to use the DMZ server 1 rule. And if it matches a destination address of 1.1.1.1, and we're going to do this by going to host 3 and running some ping commands. We'll do SSH, and also we will test 443 connections to the destination of 1.1.1.1. And so what this should do is NAT this traffic, or translate it, to the pool of DMZ server 1, and that is going to be the 11.2, or the server 1's IP address, the private IP. So if all goes well, we should be able to go to, we'll go ahead and commit and quit. We should be able to go to host 3 and start some of this traffic. And then we can verify that it's working on the SRX by doing some commands, some verification commands, some show commands. So let's go to host 3. We will start by simply doing a ping 1.1.1.1, and we'll just do a rapid count of 10. So let's go back to the VSRX. Before we do that, we'll do a show security flow session. And I like to do pipe refresh, and this will run the command every so often. You can set a timeout or a timer on that so it refreshes in certain time intervals. I just like to use the default. We'll go ahead and start that ping from host 3, and we'll see what happens. And as you can see on host 3, all 10 pings were successful. We got replies on all of them. If we go back to the firewall, we don't see that traffic. Sometimes you won't catch it in the security flow session. So let's go ahead and slow those pings down. Instead of doing a ping rapid, we'll just do a ping. Okay, let's go back to the firewall. Now we can see that we see that traffic. So let's go ahead and stop this on the VMX. I'm sorry, on host 3. So we should have about 15 to 16, maybe, I don't know, how many is this? 1, 2, 3, 4, 5. We should have 17 hits on our policy. Let's go back to the firewall. We'll stop this, and we'll talk about this in 1 minute. So let's do a command show security NAT destination. And if I do the command rule, let's just do DMZ server 1 rule. And as you can see, we have 17 translation hits. So it appears as though this traffic is hitting this NAT policy that we have created. So if we go back up to the security flow session command, which is one of my favorite commands, we use it all day long troubleshooting issues on Juniper firewalls. And I can tell you why. What we see here is we see bidirectional traffic. We see traffic coming, hitting the firewall and returning back to the firewall. The traffic is coming in from 13.2, which is host 3's IP address. That's the source. And we can see it going to destination 1.1.1.1, which is the simulated server 1's public IP address. And we can see the traffic returning to the firewall from 11.2, which is the private IP address for server 1. And it's returning to host 3. So this appears to be a good policy. We're seeing some traffic hits on the ICMP or the ping traffic we sent. We're seeing translation hits on the NAT policy, the destination rule that we created. Let's go ahead and simulate some more traffic from host 3. We'll just do an SSH for port 22 traffic. We'll go back to the firewall. We'll do a security flow session refresh, and let's go ahead and... So it appears the SSH, it looks like a normal SSH session should. We're getting a prompt to connect. So if we go back to the firewall, let's look at this traffic. We see the traffic with the destination from host 3, that's the source, going to the destination, which is server 1's destination NAT IP address, and the port associated is 22. And then we see traffic returning from the internal private IP of server 2 back to host 3. So it appears as though we have a successful destination NAT translation. I'm sorry, a successful destination NAT session which is occurring. Okay, so we'll do one more test. If we go back to host 3, we're going to do a telnet port 443. And we'll do 1.1.1.1. This is going to simulate. Oh, wait, one more thing I wanted to do. I just did the SSH. If I look at the security policy, the NAT policy, I should see one more translation hit on that. So before we move to 443, let's look at that rule. And you see it's incremented up 1 from 17 to 18. So it appears as though that SSH traffic is hitting that NAT rule. Okay, back to host 3. Let's go ahead and try the secure web traffic. Let's do a security flow session and we'll try again. Let's give it a couple of tries. Okay, there we go. So back to the firewall. You can see the host 3 13.2 trying to reach the destination NAT IP, the public IP of the web server 1.1.1.1, and the destination port is 443. So we see packets bidirectional. We see packets entering into the firewall and returning back. And the return traffic is coming from the private IP. So this looks like a good connection. Our NAT policy, if we look at it, so now we have about 25 hits. So that's incremented up from 18 to 25. So everything seems to be working. Let's go back to our diagram from host 3 to server 1. So let's now add the destination NAT policy on the firewall from host 3 to server 2. So we're going to allow all inbound traffic. And what we're going to do is we're going to create a NAT policy to NAT the destination of 2.2.2.2 to the 12.2 IP address on server 2. So let's go back to the firewall. We'll get into configuration mode. We'll do the command set security NAT destination pool. And so if we do a question mark, you see that we have DMZ server 1. Let's go ahead and do DMZ server 2 underscore pool. And we're going to put the address of the private IP of server 2. So that's 10.122.2/32. And so now we'll define the rule set. And then the last step is we'll go ahead and apply the policy. So we'll do set security NAT destination rule set. And you can see that we already have the rule set DMZ server underscore rule set. We can just reuse that. And we'll just add another rule to the rule set. So we'll do DMZ server rule set. And again, we have to specify the zone. So we'll do from zone untrust. And the next thing that we'll define is the actual rules themselves. It's going to be rule. We'll just use the same format that we used for, sorry about that. So we'll go from, we'll just do this, rule, question mark. So we'll do DMZ server, instead of server 2, I'm sorry, server 1, we'll do server 2 rule. And we'll match the destination address of 2.2.2.2. And that's going to be a /32. And we will end with our action, and that's going to be to then use the destination NAT pool of DMZ server 2. So we'll go ahead and hit enter. And we'll go ahead and do a show pipe compare. And you can see now that in addition to rule, the DMZ server 1 rule, we are now creating a new rule and a new pool. So we have the second pool, which is DMZ server 2 underscore pool, where we defined the IP address. I think that's actually wrong. Let's go back to our diagram. That would be bad. So let's go back to, yeah, that's wrong. We put 22.2, that should be 12.2. So let's go ahead and make this 12.2. Okay, there we go. Okay. So now that we have the correct, that's why it's always good to do a show pipe compare, just to go through and verify your configuration, and also do a commit check. Even though a commit check would not have given us any errors, the show pipe compare, at least we were able to verify the correct IP. We had to replace the 22.2 with 12.2. So that's the server 2 private IP. And now that we have the second rule listed is the DMZ server 2 rule, where we're going to match the destination NAT IP of 2.2.2.2. And this is where we translate that traffic or map it to the DMZ server 2 pool that we created, which is the 12.2. So we'll go ahead and commit and quit. And a good command that I like to do is we'll go ahead and clear the security NAT statistics on the destination rule. You can specify, we'll just do all. And we'll go to host 3 and let's go ahead and see if this works. So we'll do similar to what we did for the connection to server 1. So we'll go ahead and run a ping to 2.2.2.2. And let's go back to the SRX. We'll do a security flow session refresh. And we'll let the traffic go. So let's go back to the firewall. We see the traffic now. All right, let's go ahead and stop this. Go back to the firewall. And you can see that we have bidirectional traffic. That's our first indicator that things might be good. It's not always true, but in this case, for the simplicity of the lab, it is. We have host 3, 13.2 is the source. We have the destination NAT IP 2.2.2.2. We see that ICMP or ping traffic coming in gig 002, and it's leaving and returning to us from 001. So it's coming back to us from a source of 12.2, and that's server 2's private IP. So let's go ahead and look at the rule. So the rule is going to be DMZ server 2 rule. And you can see that we have 8 hits. So that looks right, because we had about 8 packets from host 3. Okay, so if we go back to the firewall, we'll just do the up arrow, and we'll start the security flow session. Let's go ahead and generate some more traffic from host 3. Let's do SSH. And so now we have an SSH connection running to server 2. Let's go ahead and stop this traffic. We'll go back to the firewall. We can see bidirectional traffic. We see packets incrementing into the firewall and out of the firewall. We see host 3, which is 13.2, making a connection to the NAT IP of 2.2.2.2. And then we can see the NAT policy, which is the destination NAT. We see the return traffic from server 2, which is 12.2. So the last thing we're going to do in the lab is we will go back to host 3 and we'll simulate secure web traffic. So we'll do telnet port 443 and the destination IP. Let's go ahead back to the firewall. We'll get the security flow going. Before we do this, I was going to show you we should have now 9 translation hits. Let's go ahead and look. And there you have 9. So we're good to go with the SSH. Let's go ahead and start the security flow. And back to the host 3. We'll just simulate a couple of these 443 connections. And there we have a hit. So the hit shows traffic from host 3 to server 2's public IP via 443, our secure web traffic. And we see this bidirectional, and it's returning back to the firewall from the private IP of server 2. So this looks good. What we've, let's go to show configurations. So we have the two rules and the two pools that we created. Pool 1 for server 1 and pool 2 for server 2. And same thing with the rules. We have rule 1 for server 1, the destination NAT, and we have rule 2 for the server 2 destination NAT. And again, that's to bind together the destination address. In this case, we use the loopback 0 interface to simulate that. And we're binding that connection to the inside IP address of the server in the DMZ. So that's it. I want to thank you again for joining us for the Juniper vLabs lab number 6. This was network address translation, destination NAT. If you guys and girls want to follow us step by step, you can go to the link in the video in the description. We have to our GitHub account, and we have the step-by-step guide. We have a README that explains what we're doing, the step-by-step guide, which is the instructions on how to perform the whole lab, and then we also have the initial device configurations for the firewall. So thanks again for watching, and I hope to see you in the next video.